Alright, let's look at the homework 9.4, problem number 6. Alright, so let's solve this logistic model problem. Alright, so use the fact that the population was 25 million in 1990. So that's where t equals 0. So that's the initial value. So I'm going to just mark that. So this is going to be the initial population. So I'm going to call it the P0. Alright. And formulate logistic model for US population, and assuming that the carrying capacity is 3,000 million, so it's M. Alright, and assume P is the population in millions, K is relative growth rate, and T is the timing. Alright, so we already know that this is going to be M, so 3,000 over 1 plus, we have to find A, but A is going to be simply carrying capacity 3,000 minus initial population, so it's a 250 divided by 250. Alright, so this is going to be, so 3,000 minus 250 is 2,750. And divide by 250. Right? So what's that? So we can cancel zeros, divide through by 10, and let's see, 27. You can put the 125 in there, and the 25. So it's going to be 11. Right? So it's 11 e to the negative kt. Right? So let's type it in first and make sure that this is correct. So we had 3,000 divided by 1 plus 11 e to the negative kt. Right? So I'm going to go ahead and check the answer, submit for testing. Alright, it came back and it looks like we got the part A correctly. Alright, so let's do part B. Determine the value of K in your model, knowing that the population in 2000 was 275 million. Right, so let's do that. Alright, so remember that 2000, so here's 2000. Since the starting year is 1990, 2000 means that t is going to be equal to 10. Right? So all we have to do is use the fact we can just plug in t equals 10 into a population function. So I'm going to go ahead and do that. I'm going to go down here. So p of 10. So this is going to be 3,000 on top. And then we have 1 plus 11. All right, e to the, so we have to plug in e to the negative 10k, right? And then this is going to be equal to 275 million, right? So let's find the k value from here, right? So first I'm going to take the reciprocal of both sides, right? So you have a 1 plus 11 e to the negative 10k over 3,000, and that's equal to 1 over 275. Right, so we got that. Then let's see, we want to get rid of 3,000, so I'm going to actually go ahead and multiply by 3,000. Right, so that way we can cancel 3,000 on the bottom. Then we can just put here 3,000 on top. Right, so if you divide 3,000 by 275, you're going to get, let's see, if you put 300, you can put the 275, and then you have 275 left, so it's going to be 11, right? So we have that, then we can subtract 1 from both sides, then you get the 11 e to the negative 10k is equal to 10. 11 minus 1. All right, and then we're going to divide through by 11. So we divide through by 11, divide through by 11. Then we can cancel 11 on top and 11 on the bottom. All right, then we can just, next step is take the natural log of both sides. Then you can see that it's going to be just a negative 10k, which is equal to natural log of 10 over 11. Right, which is going to be a negative number because 10 over 11 is less than 1. So we're going to divide through by negative 10. So divide through by negative 10. We get the k is equal to negative natural log of 10 over 11 over 10. Right? So we want to round your answer to 8 decimal places. All right, so I definitely need that GeoGebra. So let's open up a GeoGebra here. All right, so I open up a GeoGebra. So then we want 8 decimal places. So I'm going to just rounding, change that to, we don't have 8, so I'm going to do 10. All right, then I'm going to do, let's see, negative. All right, then we have a natural log. I guess we can do natural log of 10 over 11 and divide by 10. All right, hit enter. All right, so we get 0.009531 and 0. All right. So let's see if I can remember this. All right, I'm going to put the 0.0095 first. 0.0095, all right, and then 310. 310. So I think that's enough. All right, so let's type this number in. All right, k, it came out to be 0.0095 and 31. All right, so let's submit for testing. All right, actually I have to do 8 decimal places. I forgot. So it's 1, 2, 3, 4, 5, 6. I only did 6, so which means that 0, 2 would be the 0, 2. That's probably how I should end it. So let's check again. Sorry about that. All right, let's look at the homework 9.4, problem number 6. All right, so let's do this logistic model problem. All right, so let's see. It says that the fact that the population was 250 million in 1990, where t equals 0. So this is our initial population. So this is P0. All right, so we got that. All right, then carrying capacity is 3,000 million. So this is going to be our M. All right, assume P is a population in millions, K is a relative growth rate, T is the time in years since 1990. All right, so let's do that. All right, first we have to find the A value. So A is equal to, all right, carrying capacity is 3,000 and minus 250 over 250. So that's the initial population, right? All right, so this is going to be, all right, so if you subtract, let's see, 250, so 2,750 divided by 250, right? So I'm going to divide top by 10 and bottom by 10. All right, so if you divide 275 by 25 would be, if you can squeeze 1 in there, so it's a 25, so 25, so it's going to be 11. All right, so the P of T is going to be carrying capacity, so 3,000 divided by 1 plus A came out to be 11, e to the negative KT. All right, so let's type this guy in. Right, so we have 3,000 divided by 1 plus a is 11 e to the negative kt. Right, so let's double check, submit for testing. Alright, it came back and looks like we got part A correctly. Alright, so let's look at the part B. Alright, determine the value of k. Right, assuming that in 2000, population became 255 million. Right, so at 2000, we know that that's t equals 10, right? Because we're starting at 1990. Right, and you have a 275 million. Right, so let's compute that. So population after 10 years is going to be, so following the formula, so you have a 3,000 over 1 plus 11 e to the, right, t is 10, so it's a negative 10k, and this is equal to 275. Right, so let's solve for k. Right, so first is I'm going to just take the reciprocal of both sides. Right, put everyone upside down. So you have a 1 plus 11 e to the negative 10k over 3,000 is equal to 1 over 275. Right? Then I'm going to multiply both sides by 3,000. Right? That way we can cancel 3,000 out, and then we're going to have to put 3,000 there. Alright, so let's simplify a bit. So it's both multiple of 5. So if you divide by 5, you get 5 times 5 is 25. And you have another 25, so 5 times 5 is 55. So divide by 5 is going to be, so divide by 30 is going to be 6 and 100, right? And another 5, so divide by 5, so you have 11. And divide by 5, it's going to be 120, right? So it looks like, I guess, I think that's the best we can do. So this is going to be 120 over 11, right? Then after that, we just have to solve for k. So I'm going to get rid of 1 here, subtract 1. Alright, so it's going to be 11 e to the negative 10k is equal to, right, if you subtract 1, so we have to subtract 11 over 11, so it's going to be 109 over 11, right? Then divide through by 11 here, so it's going to be divide through by 11, so we can cancel 11 here, and you have another, so it's 11 squared, so it's a 121, right? Then after that, we just take the natural log of both sides. So natural log of both sides, you're going to get the negative 10k, which is equal to natural log of 109 over 121, right? So that's not a very nice number. All right, but then we're going to have to divide through by negative 10, right? So k is going to be equal to, right, negative, right, natural log of 109 over 121 over 10, right? So let's get this value using GeoGebra here, right? So actually that's not the correct one. All right, so we need to compute, let's see, so negative natural log of 109 divided by 121, then divide by 10, right? Let's hit enter. right? I'm going to, let's see, have to change the rounding to 10 decimal places, right? So let's see, so we have to keep 8 decimal places, right? So it's going to be 0.010444. Let's put that 0.010444. So that's 1, 2, 3, 4, 5, 6, and I need 2 more decimal places. So 2 more, so 4. So it's going to be 27. 27. Right, so let's type it in. All right, so we got let's see, 0.0104427. All right, did I get that? 1, 2, 3, 4, 5, 6, 7, 8. All right, that should be right. And let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, then part C, we want to predict the population year 2010, oh actually 2100 and 2200. Alright, so let's do that. Alright, so let's see, so year 2100 would be, let's see, 110. So P of 110 would be, right? So we just have to do this here. 3,000, right? Over 1 plus 11 e to the negative k. So negative 0.0104427, and the t is 110, right? So let's compute that, right, using GeoGebra here. All right, so you have 3,000 divided by 1 plus 11 e to the negative 0.0104427 multiplied by 110, right, and hit enter. All right, so round to the nearest person, so it's going to be 669. 669. Near. Oh, wait a minute. It's a nearest person. All right. So it's not the nearest million. All right. So let's recompute that. All right. So it'll be million. So you need to have 6 more. So it's going to 668.60. I'm gonna have to keep track of the 606, and then I need 3 more. 587. All right, so let's type it in. All right, so 668. So we have 668 point and 606, 606, and 587, 587, 587, right? So let's check the answer, submit for testing. All right, it came back and looks like we got this one correctly. All right, so year 2200, so that will be 210 for T. So I'm going to just go ahead and do that. So here, I'm going to just do the formula, right? So it's going to be 3,000 divided by 1 plus 11 e to the, right, negative 0.0 10.44427, and then multiply by 210. Right? So this is going to give you that. Alright, so this is going to be 1347. Alright, 1347 point, then 6 more, 084. So I'm going to put the 084, and then 084 127. 127. Alright, so let's check the answer. Submit for testing. Alright, it came back and looks like we got part C correctly for both of them. Alright, so let's do part D. Alright, part D. Use your model to predict the year in which U.S. population will exceed 350 million. Alright, so we're going to have P of T, which is 3,000 over 1 plus 11 e to the negative kt. I'm going to leave k as k. I'm going to plug it in later. And we want this to be, so let's set it equal to 350. Alright? Then we just have to solve for t. Alright? So this is going to be, alright, take the reciprocal of both sides. So we have a 1 plus 11 e to the negative kt over 3,000 is equal to 1 over 350. Right? And I multiply through by 3,000. That way we can get rid of 3,000 here, and I'm going to put the 3,000 up here. Alright, then I'm going to just simplify. So it's a multiple, actually knock out one of the zeros. Alright, multiple 5. So this is going to give you 7. Divide by 5 and 60. Right? So you have a 60 over 7, and then I'm going to subtract 1. Alright, you're going to get 11 e to the negative kt is equal to, alright, 60 over 7 minus 1 is 7 over 7, so it's going to be 53 over 7. Right? Then I'm going to divide through by 11. So you're going to get e to the negative kt is equal to 53 over 77. Right? Then we're going to take the natural log of both sides. Alright, so you're going to get the negative kt is equal to natural log of 53 over 77. Alright, then if you want to find t, so we're going to divide through by negative k. Alright, so t is equal to natural log of 53 over 77 divided by negative k was 0.01044427. Right? So let's compute that, and I'm gonna bring out the GeoGebra here. Right? And then I'm gonna do a natural log of I'm gonna just put the negative sign here, and the 53 divided by 77 and divide by 0.01044427, and hit enter. Alright, so let's see, use to predict the year. So it's going to be 35.7. So I guess that the year is going to be, let's see, so you're going to have to add, right, 35, then a little bit more, but I'm going to just add 35, so it's going to be 25. All right, so here is going to be, so I'm going to do just a 190 plus 35. All right, so this is going to be, let's see, 5 here and the 2 here, then 2025. All right, so 2025. All right, so answer is going to be 2025. All right, so let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.